All right, looking at number 15, we're asked to do an indefinite integral here, and what I was kind of hoping to see, there are two distinct parts to the integrand right here. Now, usually though, we're looking for a difference in degree if we're polynomials. Like for example, if this was an x squared and this was an x, that would make me think that I should let u equal this part. It's a little odd, a little unusual in this problem that the two parts are both linear. But what you will notice right here, guys, is that what we have here is a binomial being taken to a power and then a monomial that's just kind of out there by itself. We want to flip that around. So that's why we're going to let u equal, and I tell you what, I'm going to usually do green for some reason for my u substitution. We're going to let u equal the binomial base of that exponent, x plus 1. Now, when we go to differentiate that, we're going to get du is equal to, and the derivative of x plus 1 is just going to be a 1, and we'd stick a dx at the end of all that, and this can feel like a dead end right now. Let's see where we are. So this would now become the integral of, all right, our primary substitution right here, the x plus 1 becomes a u, and that's raised to the 9th power. No problem there. The dx right here is just going to be replaced by a du, so no problem right there. But the other problem is that we still have this x floating out here that we haven't covered yet. So this is one of the rare situations where, in addition to coming up with your initial substitution, which is on this line right here, and then going down a level to get du and then the dx, we also need to go up right here. We're going to solve this initial equation here for x just by subtracting 1 from each side, and we'll get u minus 1 is equal to x, and that's what we're going to need to put in right there. So the x is now going to get replaced by the binomial quantity u minus 1, and that'll go right there. Now, have we actually accomplished anything? Well, the first question is, have we replaced all of the x's and the dx with u's and du? And the answer to that is yes. But the second question is more interesting here. Is this new integral actually any easier to evaluate than the one that we started with? And it might not look like it at first, but this is something you guys are going to have to get good at recognizing. One major change happened right here, and it's something that makes this problem now possible when it wasn't before. We flip-flopped the initial setup of this problem. The initial setup had a binomial to the 9th power times a monomial. Now we have a monomial to the 9th power times a binomial. Now, it doesn't seem like much, but why is it important? Because we can now distribute the u to the 9th into that binomial, and we can rewrite this integrand now in expanded form without any parentheses. So the u to the 9th times u is going to give us u to the 10th, and then minus a u to the 9th, all taken with respect to u. So now with that expanded form, we're simply reversing the power rule on each of these two individual terms, and this antiderivative isn't going to be difficult to come up with here at all. So anti-differentiating u to the 10th, we're going to raise our power by 1, which is a u to the 11th, and divide by that new power. So I'll put a 1/11th out in front of that. And then a minus, same concept here. This is going to be a minus 1/10th, and then u to the 10th at the end of all that. It's an indefinite integral, so we'll put a plus c, and now really all we have to do now is resubstitute or unsubstitute, however you want to call it, and put x plus 1 back in there for our u's. So I'm going to write this as a 1/11th, and then times, that'll be an x plus 1 to the 11th power, and then minus a 1/10th, x plus 1 to the 10th power, and a plus c at the end, and that should be all we were looking for here on this problem here for problem number 15. All right, so that's our answer right there, and the key there was, guys, to flip-flop the binomial and the monomial. We always want it to be the monomial that something more complicated is happening to rather than the binomial.